Okay, so last time we finished talking about chemical rocks and biochemical rocks, and where we get some of our resources like oil and petroleum from these biochemical rocks. But now we're going to kind of move on to talking about some of the sedimentary processes here. But I first wanted to interject here a little bit and talk about where we find sedimentary rocks in North Carolina. So North Carolina is broken apart into three basic physiological provinces. What we mean by that, but we often break it off into smaller groups as well. So the three main ones that you guys usually hear about is what we call the Blue Ridge Mountains, the Piedmont, and the Coastal Plain. Okay. Then we can break it down into smaller ones, which we call the Intercoastal Plain and the Outer Coastal Plain, and then, or sometimes what we call the Tidewater, and then we call the Sand Hills, which is in our neck of the woods. So I'll talk about these in just quickly. So here we have the Blue Ridge, which is mostly our mountains, right? And those were formed there from collisions of plate tectonic activity a long time ago, and we'll go into those later when we talk about plate tectonics. But these are these hard cores of mountains, and those hard cores of mountains have slowly over time been eroded away. And this is where they're actively being eroded, and this is where they've mostly been eroded away. So these are the Piedmont is an area where you're transitioning from the mountains, okay, to this kind of rock surface or plateau of these hard rocks that have been eroded away slowly over time. Where the coastal plain is where all that sediment that was from those mountains were transported down and then deposited in this big region, which we call the coastal plain. Now, sea level used to be a lot higher, and the sea level used to, the highest it ever got to this place that we call the fall line, which is basically between us here and like Rockingham. Rockingham is kind of where the fall line is. Whereas where you have the highest level of where the ocean ever got. So when these rivers came down, they would deposit the sediment down here in this coastal plain, forming this big, thick wedge of sediment. So we have lots of sediment here in the coastal plain. It's the reason why we have a nice flat region here. That's also why some people call this neck of the woods the sand pit, right? Because we have so much sand from these beaches that used to be in this area. Now, the sand hills are also remnants of beaches, but they're often also what we call old sand dunes and stuff like that that were deposited from deltas and things like that, where the rivers were coming down, depositing this huge accumulation of sand and then forming these sand hills. And these sand hills go from here all the way down into South Carolina. Okay, so it's an abundance of the sand deposits from old beaches and deltaic sands and even sand dunes when the sea level was a lot higher. Okay, so just realize that we have these different transitions. We have mostly igneous and metamorphic rocks in the Appalachian Blue Ridge area and then the Piedmont, and then we have tons of sedimentary rocks down here in the coastal plain. And we still can find sedimentary rocks in both of these segments, but you're going to find them more in abundance down here and more metamorphic and igneous rocks up here. Okay, so when sedimentary rocks are deposited, they also preserve other information about their what we call depositional environments, the environment in which they were that sediment was deposited, right? So we can look at their composition. Was it made out of quartz, feldspars? What kind of minerals were there, right? So if it was from granite, you could maybe have gold in there. Okay, so we can look at the mineralogy of this deposit. We can look at the grain size of the deposit. We've talked about that with sorting, right? But we also can look at what we call sedimentary structures. Now, structures are what we can see as in the deposits themselves, or the patterns within the deposition. One example of this is what we call bedding or layering. So bedding can be very thick, where, for example, this is the Vasquez Formation. I think this is in New Mexico, if I remember right, where these really thick beds of sand were deposited. Or you can have things like this is the Burgess Shale Formation up in Canada. We have these really small, thin beds, right? So they can be from fine beds to massive beds. Okay, so that's depends on the deposit. So if you have a big storm deposit, you're going to get a larger bed. Slow deposits, maybe in a lake environment like you do, or an offshore environment like you do in the Burgess Shale here, you're going to get nice thin deposits, right? So that layering, though, happens slowly over time. And so this bedding or stratigraphic layering is the division of those sediments over time. You can see that layering and that bedding in the Grand Canyon here. You can see all the different layers of sediment. Okay, so over time, as ocean surface sea levels going up and down, they leave behind different deposits as it goes. So, for example, in this first one here, you might get this little sand deposit. Then you might get some shales, because that sand deposit might be because sea level is high, and then maybe sea level goes up even higher, so that place where we used to deposit sand now deposits shales, finer grain materials. Maybe the sea level goes back down, and so now you get sand deposits back on top of it, right? So you get these layers of sand, mud, and sand. Well, then, so usually these layers are in these horizontal layers, because when you think about it, gravity and a fluid is going to go downhill and then spread out. And so that sediment is going to be spread out as well, so forming these nice horizontal layers over time. Now, if something cuts through those layers, we call that superposition. So the oldest layers here, the oldest rocks, are at the bottom of the canyon. The younger rocks are on the top, and the river itself that cut through this is actually the youngest. So it's cutting through all these deposits, right? So that's kind of a way we can figure out timing of different deposits as well. Cross-bedding is a feature that we can see often done in wind deposits, or like sand dunes, or even some river deposits. But basically anywhere where a sediment can be pushed up a slope and then slowly fall off as the current goes by, okay, will leave these cross beds. Now, if they're small-scale cross beds, there will be what we call, they can happen in rivers. But usually large cross beds like this one here are usually due to large sand dunes. So what will happen is the wind will go up on this side, and then it can't carry it anymore, so it will fall down on this side, deposit, leaving these nice beds over time. And then slowly it will be eroded off on the top here to form this big bed here of this material. Okay, so this actually even tells us the direction in which the sand was moving at the time when the wind was moving. So the wind was moving in this direction here, because you'll see the sand goes up and then down. Now, it's all that's preserved is what's below this down here. So this tells us that the wind, when this deposit was deposited, was going in this direction. Right? Kind of cool to be able to understand. If by just looking at a rock, I can tell you which way the wind blew when that was deposited. This could have been deposited during the time of the dinosaurs, this is in Zion National Park, so it would have been deposited in the time of the dinosaurs. 65 million years ago, I knew the wind was blowing in this direction, going that way, right? So if I actually found another rock, let's say I found this rock and I see evidence of old ripples in it. Now, you guys have probably seen ripples before. At a beach, you might see ripples. And this is from the waves going back and forth, depositing the sand in different areas. So you have the cross-bedding, small-scale cross-bedding. So I see here, and maybe even in here. Okay, but you also see how it goes up and down, up and down. So those preservation of ripples tell us something. They tell us that this used to be deposited by either wind or water, and you have some kind of a current, right? And so the current in this direction is one-sided. So you can see that the water was going in this direction. You can see the same thing here, where the current's going down like this, so the water was going in this direction. Okay. And so, however, sometimes you can't tell which way it is because the waves are going in both directions. Okay, so that's maybe at a beach deposit. This one here is at a river. You can tell because of the direction in which the cross beds go. So, but those are our clues to tell us once again what happened in the past. Another example of a sedimentary structure is what we call a mud crack. Well, if you have a lake bed, okay, it had water in it, and then it dried out. That clay will actually crack up, forming these mud cracks around it. And let's say you had another flood come through, and all that sand or something else goes back down to those cracks. Well, what will be left behind are these surfaces that look like mud cracks, right? And they're preserved in the record here. So we can see that this used to be a place that dried out. So it could be a place that's got an old stream bed, or maybe an old river bed, an old lake bed or a pond that dried out. So a place that might have some periods of wetness and dry. Okay, so maybe in a desert landscape. Okay, so another thing that we can see is what we call graded bedding. Well, if we have a big flood and it has lots of sediment in it, then what's going to fall down to the bottom first? Well, the big stuff. The big stuff's going to fall down to the bottom. The fine stuff's going to fall down on top. Okay, as it slowly gets deposited. So in each of these flood deposits, you have coarse stuff on the bottom, fine stuff on the top. So this can give us an understanding of big floods, maybe landslides. That's always the big stuff's going to go to the bottom, small stuff's going to go to the top. So this gives us indications of what can happen in the future. You can get this in what we call small scale, like in this couple centimeters here. We have the coarse stuff at the bottom, fine stuff at the top. or you can do it in a very large deposit where the environment's changing from a deep channel, maybe to a shallow channel to a floodplain, so you can get coarse deposits to fine deposits over time. Okay. Now, colors of rocks can also tell us a lot of things about a rock as well. And if a rock is dark in color, like this coal, or even here we go, this limestone, the darker it is, usually means that it has stagnant water, or and usually has not a lot of oxygen there, right? So the organic material gets left behind and actually gets preserved. Whereas in places like in terrestrial, above water places, that organic material will decay, and so therefore it's not preserved. So when you get up into these kind of colors, the lighter colors, you tend to be terrestrial waters. Green and gray tend to be kind of more shallow, and if you get all the way up to the top, you will have, that means that sediment is actually been interacting with oxygen, so you tend to get iron oxide, and you get these red beds, right? So if you get a rock that's red, like this rock right here, which you can actually even has, let's see if I can show this one to you. There we go. It even has ripple marks on it. It shows that the current was going back and forth here, but it has this reddish hue to it. There's lots of iron in this, so we know this was actually deposited in probably a river system or a shallow sea. It's probably more shallow sea because just looking at the oscillations here on the ripples, but has been exposed to air, and therefore all the iron has been oxidized. Okay, so it came from some terrestrial landscape. Now, fossils can also tell us a lot about an environment. Okay, so for example, this has lots of different fossils in it, and this kind of shows you where all those fossils came from. But what's cool about this is all these fossils here all came from one place, and it came from a place called Green River, Wyoming. And if you look at this, there's lots of different fossils in here. We have alligators, mosquitoes, birds, bats, palm fronds, turtles, stingrays, snakes, and lots of other different animals that we see here in plants. Okay. Well, what's a place in the world that has alligators, palm fronds, bats, turtles, and stingrays? You would suggest that this might have been a place where you had maybe an estuary, okay, or a swamp near the coast somewhere, where you have input from seawater but also freshwater organisms. Okay, and so, well, this was all found in Wyoming, and there's palm fronds here too, and that's a warm environment for that kind of plant. So what we can infer from this is in Wyoming, we used to have all of these organisms. So that means that there used to be a connection at one time to the sea. There used to be a connection at one time to a warmer climate. And now that place is freezing cold. And it's one of the coldest places in the United States sometimes because it's how far interior the continent it is. And so, but today, in the past, it used to be a much warmer environment. Okay, and so this sediment, I have an example of this fossil we call this the Green River Formation, has this sediment might be the siltstone from the bottom of a lake. Okay, that silt would have to fall out from this low energy environment, so that silt would slowly fall at the bottom of a lake, and all these organisms basically died, fell on the bottom of that lake, and then the sand and the sediment would deposit on top of it, preserving those fossils, right? But it tells us that locality, first of all, was probably a lake because of the fine grained materials. It once was connected to the ocean because we have a stingray. It had a warmer environment because we have this palm frond and alligators that live like warmer environments. It tells us a lot about the background. Here's another one. This is a trace fossil of a dinosaur footprint, right? And this dinosaur footprint tells us that this organism was actually walking in some clay or some mud. And we can even understand the weight of this organism because of the composition of the soil and looking at how big this organism was and understand how heavy it was, right? Okay, maybe understand what kind of organism it was. So fossils can tell us a lot about the past based off of the remnants of what was left behind.